सो आज हम पढ़ेंगे पोटेंशियल ऑफ लाइन चार्ज। बेसिकली जो एक चार्ज डेंसिटी सॉरी जो चार्ज डिस्ट्रीब्यूशन एक लाइन रॉड के ऊपर है, उसके वजह से एक स्पेसिफिक पॉइंट के ऊपर पोटेंशियल कितना डेवलप होगा वो हम डिराइव करेंगे आज। ओके, सो बेसिकली इसमें आपको तीन मेन चीज़ें याद चाहिए। बेसिकली एक पीजीटी जो हमें पाइथागोरस थ्योरम हमें 10th में पता था, एंड देन वोल्टेज का फॉर्मूला जो बेसिकली होता है 1/4πε0 इंटू क्यू अपॉन आर। जो चार्ज का डिस्टेंस है डिवाइडेड बाय द डिस्टेंस, मतलब उस पॉइंट तक लाने के लिए उस चार्ज को कितना वर्क लगा है, ठीक है। एंड देन फाइनली इज लाइक इंटीग्रेशन के एक दो फॉर्मूलेज लगेंगे हमें, विच आर रिटन ओवर हियर। इंटीग्रल ऑफ 1/√(x² + a² dx इज इक्वल टू log ऑफ x प्लस √(x² + a² + c, ठीक है। और एक दूसरा होगा जो इंटीग्रल, जो डेफिनेट इंटीग्रल का फॉर्मूला है, जो इंटीग्रेशन ऑफ लोअर लिमिट टू अपर लिमिट लगता है -a to +b ऑफ f ऑफ x dx इज इक्वल टू जो f कैपिटल F ऑफ b माइनस कैपिटल F ऑफ -a। जो बेसिकली कैपिटल F का मतलब क्या होता है, जो आप इंटीग्रेट करते हो छोटा फंक्शन, उसमें से जो नया फंक्शन जनरेट होता है वो दैट इज डिनोटेड बाय कैपिटल F। सो लेट्स गेट स्टार्टेड विद द डेरिवेशन इन द फर्स्ट प्लेस। सो लेट्स अंडरस्टैंड द बेसिक डायग्राम फॉर द डेरिवेशन इटसेल्फ. So this is our rod. This is a straight rod of the length spanning from -a to b. That's basically let's suppose it to be total L. Okay. So the next is here is a point. So which is at a distance r from a specific small element, that is plus. So here plus sign will denote small elements on the rod. Okay. Plus the small amount of charge that is there on those plus elements will be denoted by lambda times dx. So what is lambda? Is the linear charge density. That means the total charge on the rod divided by the length of the rod. That will give you the amount of charge in a unit length of the rod. Okay, so that will be lambda, and times dx is for that small amount. For that small amount, dx is the small amount of length of the rod. Okay, so if I multiply lambda times dx, I will get the small amount of the charge in that small element, that is dx. Okay, it derives from the formula of lambda is equal to dq over dx into dx. So dx cancel, we get dq, so which is written over here. Okay, so lambda is equal to dq over dx, so multiply by dx, we get finally dq. So next is this is a small element plus, this is a point that is I have not denoted it by anything. Let's denote it by p. Okay, let's denote it by p. So point p, at this point we want. So let's get started. So capital V is equal to integral of k times dq over r. So dq is the small element charge, that is dq, divided by the distance r. Distance r is the distance from the point, distance of the point from that small charge element plus. Okay, so which is equal to integral from -a to b. So now I want to integrate, like I want to calculate the entire potential that is there at this point due to the whole rod. So that is why I am integrating from -a to +b. Okay, and we will use the same formula but in the infinitesimal terms, like dq over r. Okay, so that's what we are using here. So k times dq over r is converted into k times lambda dx. That's what I told you here, dq over dx into dx. So that will give you dq. So lambda dx over r. Okay, so which is equal to integral from -a to b k lambda dx over √ of x² plus d square, which is derived from this small little triangle over here. Okay, see what we did is we drew a straight line, perpendicular line to this rod at a distance, the point of the point p to the rod, a perpendicular line which is which denotes the distance between the point p and the rod. Okay, which is d, and this hypotenuse that we have got, that is the distance, the real distance r of the point from that charge element. Okay, so now we will use the Pythagoras theorem to figure out the linear distance, that is the the straight perpendicular distance between the point and the rod. Okay, so the d. So that we know by Pythagoras theorem is r is equal to √ of x² plus d square, that is the lower x² plus d square, the linear distance. So that we get basically r is equal to √ of x² plus d square. So that's what we substituting here. Okay, in place of r. So after that we go down to we integrate this thing. Okay, we evaluate this integral like this. So constant terms will come out, basically k and lambda are constant terms, so they will come out basically, and we'll get the integral of dx over √ of x² plus a square. So once we get that, we'll use this integration formula of integral of 1/x² plus a² dx is equal to log of x plus √ of x² plus a square plus c, to evaluate this integral which is left over after removing after taking the constant outside the integral sign. Okay, so after the integral is obtained, then we will apply the rules of definite integral from lower limit to upper limit, and upon doing so we will get like this. So log of b plus √ of b square plus a square plus c minus. Now this is going to be minus, and then the lower limit will be substituted. Log of minus a plus square root of minus a squared minus a squared minus d squared, minus a squared plus d squared plus minus c. So minus c plus c will get cancelled over there. Okay, and the final that we come out with the formula is natural log of b plus square root of b square plus d square upon minus a plus square root of a square plus d square, which is derived again from another formula that is equal to, that is given by, that is which is, sorry, okay, so which is given by log of a over b is equal to log a minus log b. Okay, so log a minus log b, this is the formula that we'll use to finally get to this term. Okay, so k lambda natural log of b plus square root of b square plus d square over minus a plus square root of a square plus d square. So friends, this is our final formula, and this is the end of the video.